till now we discussed open circuit voltage, which is called as source. Next one we discussed short circuit current, which is nothing but called as the effect. Next, let's try to understand about the maximum power point tracking. Okay, this is very important while you understand a solar panel. So in more clear, I am drawing here a diagram. The x-axis I am going to take voltage. In the y-axis I am going to plot the current. Okay, now when you try to perform these characteristics, generally for different voltage levels, for example solar radiation you applied, okay, and you will get some sort of voltage, then the curve will start at this point. So as the time is changing, automatically what will happen, the solar parameter will change like this. So these dots are nothing but voltage and current measured at different times and different radiations. I'm just joining all these points, which is going to develop you a structure. So now on this curve we need to identify which is the maximum power rating. So I'm marking one point for making you clear. So what is the voltage of the solar panel? That will be maximum. What is the voltage of a solar panel? That will be maximum. What is the source? Open circuit voltage. So this higher magnitude I am going to call with a name which is called open circuit voltage. I am not connecting any load, and also not connecting any load. The maximum current that is developed by an solar panel is called as short circuit current. So I am going to get this short circuit current. So these are the 2 points where I am going to have initially. Okay, so solar panel, here it is generating voltage, but current is 0. When it is possible? At night time, or not at night time, at evening 4 o'clock or 5 o'clock. At evening 4 to 5, what is there? Voltage is there, but current magnitude is how much? 0. So slowly you try to what happen? So you try to move morning 6 a.m., morning 7 a.m., morning 8 a.m., 9 a.m., 10 a.m., 12, 1, 3, like that you increase. So then you will get different magnitudes of current, but the voltage remains same. So then you will get this curve generally. So now the maximum voltage that is generated by solar panel is called as open circuit voltage. Under which condition? No load conditions, not connected to load. The maximum current that can be generated by solar panel is called as short circuit current. So that's how I got these 2 points. Now let's try to do the product. Okay, for example, you have the voltage. What is the current here? At 6 a.m. let us assume that the total rating of the panel is 12 volts, 100 watt panel rated, and the system voltage or the maximum voltage is 12 volt system, and the maximum current is some 10 amperes, which is called I maximum. Maximum current that can flow in the solar panel is how much? 10 amperes. At morning 6 a.m. I am having only 1 ampere of current. How many amperes of current? 1 ampere. But the voltage is maximum. You multiply with this voltage. What is the voltage I got? 12 into 1. 12 is to 1 is how much? So at this point you are going to get how much? 12 watts. Okay, now you see here. So slowly at 7 a.m. I am going to get how many amperes of current? 2 amperes. 2 amperes multiplied with 12 volts. This is not 12. Once again this is decrease. This is 11 volts into 2 amperes. How many it is? 22 watts. Okay, so similarly at 8 a.m. let us understand that this is also developing how many amperes? 3 amperes. So here it is 3 amperes, and coming to this point, so this is developing some 10 volts multiplied with 3 amperes, or to directly multiply with 12. So 12 into 3 is how much? 36 watts. Like that, you see here at the morning it is 12 volts, at 7 a.m. it is 22 watts, at 8 a.m. it is 36 watts. Like that, it slowly it will vary, and it will come to one point where that point is called as P maximum, and this P maximum generally will be equal to the rating of the panel. What is the rating of the panel? 100 watt peak. So the rating of the panel is 100 watt peak. At this point you are going to get how much? 100 watts. Okay, at this point this will be automatically less than this value only. So how much it will be? Some 90 watts. How much this will be? Some 80 watts. How much this will be? Some 70 watts. How much this will be? 60 watts. So below this also, this is 36 watts and this may be some 70 watts or this may be some 80 watts. So what you understand from this curve? What you understand from this curve? The parameters are changing, the power ratings are changing. So it ranges from 12 watts, 22 watts, 30 watts, 70, 80 and remaining is how much? 100 watts. After this is going to have 90, 80, 70. And what you understand from this analysis, at one point only it is trying to deliver maximum power. Therefore, I am going to call this point as maximum power point tracking, where this is called maximum power point, MPP, maximum power point. So the same you had already done in electrical engineering with the help of an maximum power transfer theorem. In maximum power transfer theorem also, if you try to plot the load current versus the power delivered, then you will get a graph like this. Yes or no? You will get a graph like this. At this point, very minimum, and slowly it increases and reaches a maximum point, where this point is called as P maximum. This point will be available only when source resistance is equal to load resistance. When source resistance is equal to load resistance, then only the maximum power is transferred. In the case of an electrical theorem, so this is what the condition fulfilled. In solar panel also, for different variations, only will get the maximum power at which time? Let's take, generally we'll take it as 1 pm and 2 pm, then you'll get which point? Maximum power point tracking point. Okay, so this is how to plot this maximum power point tracking. Next, you see here, so I already told this is VOC, and when I get this P maximum, try to draw an vertical line. This vertical line I am going to get a value which is called as V maximum. This is VOC, this is V maximum. Okay, so similarly at this P maximum, you try to draw an horizontal line. Okay, when you draw the horizontal line, then you are going to get a current where this is called as I maximum and it is indicated as IM, and where this is indicated as VM, where VM is nothing but the maximum value of voltage under which point? Maximum power point, where IM is nothing but the maximum current at which point? Maximum power point. Okay, so that's how we are going to get these two parameters, where VM is called as the maximum voltage generated by the solar panel at which point? Maximum power point. Okay, where IM is called as the maximum current generated by the solar panel under which condition? IM, corresponding to which axis? Y axis. That's how we are getting VM as well as IM. The product of VM into IM into 1. There is no power factor here. Why? Why there is no power factor? This is an DC load. In DC load, what is the power factor? Cos phi is equal to 1. That's why we will write down the power as a product of V maximum into I maximum, which is P maximum. That's how we are getting V maximum as well as that's how we are getting I maximum. So where this comes under the parameters of an solar panel. Next one is the fill factor.